Okay, today we're going to be talking about how volume affects the pressure in your gas. Because we're going to be changing the volume, we are going to consider keeping the mass and the temperature of our gas the same. Okay, so let's imagine our imaginary container filled with gas particles. Now I want you to take that container and make it smaller. What's happened to the frequency of collisions with the gas particles and the container wall? Well, each gas particle collides more frequently with the walls of the container. That's because they now have less distance to travel before their next collision. Let's make our box smaller again. And smaller. The pressure increases again. We're starting to spot a little relationship between pressure and volume. One of them decreases, the other increases. We can say that pressure and volume are inversely proportional to each other. So if I take a container of gas and I halve the volume, the pressure will double. Now, if I take a container of gas and increase the volume by a factor of 3, the pressure will drop to 1/3 of the original pressure. So it's the moment you've all been waiting for. Let's see it on a graph. So pressure on my y-axis and volume on my x-axis, and as one goes up, the other goes down, so it should look like this, right? Actually, not quite. The graph should actually be a curve like this. If you're interested in why, check out the notes in the description below. Right, now we've got the concept, we've got our graph, time to do some maths. This is how the law looks as an equation. Pressure 1 multiplied by volume 1 is equal to pressure 2 multiplied by volume 2. This is Boyle's law. Pressure could be measured in pascals, kilopascals, atmospheres. Volume could be measured in meters cubed, centimeters cubed, litres. The great thing about this equation is it doesn't matter. As long as you keep your units consistent, you don't have to do any conversions. Let's have a little look at an example question. This question is about Boyle's law, so first I'm going to write down P1V1 equals P2V2. Now I have to identify those terms in my question. So here is P1, here is V1, here is P2, and I'm looking for V2. Now I'm going to write all of that information into the correct place in my equation. Now I can divide both sides through by 1.8 times 10 to the 5 to leave V2 by itself. And if I plug that into my calculator, that gives me 8. I know it's centimetres cubed because that's what my V1 is. Okay, the next question is when the volume of gas in the syringe is increased, the pressure on the insides of the walls of the syringe decreases. Explain why, and this is worth 3 marks. Let's have a look at the mark scheme. Okay, mark number 1 is for saying there's more time between collisions, which is the equivalent of saying that my collisions are now less frequent than they were before between the particles and the walls of the syringe. That means there'll be a lower average force on the walls of the syringe. And since pressure is equal to force over area, that means there's a lower pressure in the syringe. Hopefully you found that video helpful. If you would like a copy of the notes, please do find it in the description below. Thanks for watching.